Green chemistry. In the first module is Introduction to Green Chemistry. In this module, we are mainly discussing about green chemistry, its relevance and goals, 12 principles of green chemistry, tools of green chemistry, alternative starting materials, reagents, catalysts, solvents and process used in green chemical synthesis. Let us start with what is green chemistry, or why do we need green chemistry. Green chemistry is undeniably a very prominent part of our daily life. We know that a lot of chemical developments are there during this time. That is, the chemical developments also bring new environmental problems and harmful unexpected side effects, which results in the need for a greener chemical products. A famous example is the pesticide use of DDT pesticides. Again, green chemistry is universally accepted term to describe the movement towards more environmentally acceptable chemical processes and products. Green chemistry is the use of chemistry for pollution prevention, design of chemical products and processes that are more environmentally benign, reduction or elimination of the use of generation of hazardous substances associated with the particularly synthesis or process. Next is the importance of green chemistry. We know that the environmental problems, environmental pollution is one of the current criteria that exist in the field of chemical synthesis. That is, in chemical, we know that in our daily life we are going through a lot of chemicals, and a lot of chemical synthesis are there, and because of the synthesis the waste substances are produced and they are introduced into the environment. Some of them may cause environmental pollution, and as we have already said that the use of pesticides in agriculture and the DDT, it will harmful to environment or environmental organisms. So in order to produce the more substances with the environmental less hazardous to the environment, that is very important in the field of green chemistry, or that will from this the need of green chemistry arises. The promise of green chemistry is to lower overall cost associated with the environmental health and safety. The need of green chemistry again. Chemistry has an important role to play in achieving a sustainable civilization on Earth. Again, green chemistry is the design of products and processes reducing or eliminating hazardous substances. Green chemistry is a subset of design for environment applying innovative scientific solutions to product manufacturing. There are a lot of definitions for green chemistry. It's designing more efficient processes that are minimize waste. Green chemistry means preventing pollution before it happens rather than cleaning up the mess matter, saving companies money and mitigating climate change, water resource depletion, and reducing. Overall, we can define green chemistry as a chemistry, and this is method used for reducing energy, waste, cost, risk, hazards, volatile organic compounds, environmental impact, plant means thermal power plants, and reducing materials, reducing energy. These are some of the well publicized instances from the past few decades that explains the environmental impact or the need of green chemistry, and let us discuss it one by one. And next we are going through the 12 principles of green chemistry. Through this principle we can understand what is the need of green chemistry, how green chemistry is important in the field of in a current scenario, and also for 12 principles of green chemistry. Let us discuss it one by one. And first one is prevention. First principle is prevention. Principle states that it is better to prevent waste than to treat or clean up waste after it is formed. That is, prevention is better than cure. There are some instances that can explain the prevention of pollution. One of the incident is the Love Canal incident. That is, in near Niagara Falls, a company started with a plastic company is there and had used old canal bed as a chemical dump. They dumped their waste into this canal during the period of 1930 to 1950s. Then after that, the land was used for the land is filled with the land is filled with this soil, and it is used for making a new school housing track. The chemicals leaked through a clay cap that sealed the dump and was contaminated with at least 82 chemicals like benzene, chlorinated hydrocarbons, dioxin, etc. These chemicals are leaked through the pipe or through the clay cap that sealed the dump. And the health defects were observed for the children or people living in that area, like high birth defect incidents, and also nervous diseases among children from this. This is due to the dumping of chemical waste from this plastic company, and around 82 chemicals are leaked and this seriously affected the people living in that area. So it is one of the incident is known as the Love Canal incident, and again is another incident is the Cuyahoga River, Cleveland, Ohio. There are many things being dumped in the river, such as gasoline, oil, paint, and metals. The river was called a rainbow of many different colors. But it is found that a fire is captured upon the river on June 22, 1969, when the river fire captured national attention when Time magazine reported, and then there is a notice board that is placed in the river that is highly flammable. That is, the Cuyahoga River is highly flammable because we know that because of these chemicals that may form some covering on the surface of the water, and it turns the color as chocolate brown oil bubbling with the subsurface gases, and it oozes rather than flows. Sometimes who falls on the Cuyahoga river does not drown. He will decay. That much of chemicals were dumped on the river. It is also known as the Cuyahoga incident. And from this instance, it is clear that we can prevent the pollution after it happened. We can prevent the pollution after treating it. After treating this, after treating the pollutant, or we can prevent the pollution. Prevention is better than cure. That is next. Second one is the atom economy. The second principle says that synthetic methods should be designed to maximize the incorporation of all materials used in the process into final product. This means that when we are doing some chemical process, there is rather than the main product, there are also some side products are observed, and this because side products may cause harmful to the environment, or they can be dumped directly into the river or some environmental bodies. So it is we can design chemical synthesis such as all materials used in this synthesis can be incorporated into form final product. That's we get the 100% yield of the final product. In the epoxidation of acid, we get a percentage yield as actual yield divided by theoretical yield into 100. And it is because in this process there are some equations, that is a balanced chemical equation for the epoxidation of styrene. In this side product is shown here, and the atom economy for this reaction is calculated as a formula weight of atoms utilized divided by formula weight of all reactants into 100. And if we are using all if we are incorporating all materials into final products, we get 100% yield of the main product, and 100% desired epoxide product is recovered. But the atom economy for the of this particular reaction is 23%, and about 77% of the products are waste. So if we are incorporating all materials into the final product, we can minimize the formation of side product, so we get 100% atom economy. And the third one is the less hazardous chemical synthesis. Whenever practicable, synthetic methodology should be designed to use and generate substances that possess little or no toxicity to human health and environment. Here is the polycarbonate synthesis. We can discuss it. Using an example of polycarbonate synthesis phosphine process. In this particular process, phosphine is found. We know that phosphine is highly toxic, corrosive, requires large amount of CH2Cl2, polycarbonate contaminated with the chlorine impurities. But if we design this this reaction as another method, that is solid state process, that is not polycarbonate synthesis. In this diphenyl carbonate synthesized without use of phosphine, we can eliminate the use of CH2Cl2 and we get a higher quality polycarbonates. So this according to this principle, we can design such a method for the synthesis of chemical substance which should be hazardous, less hazardous, or we can minimize the production of a side product as a hazardous side product, or we can avoid the formation of hazardous side products. And the fourth one is designing safer chemicals. Chemical products should be designed to preserve efficacy of the function while reducing toxicity. An example, designing safer chemicals case study, antifoulants. Some foulants means some marine organism that can be attached onto the surface of the wood the wood of the ship. The antifoulants are generally antifoulants are used against these organisms, and this organism is attached onto the hull of the ship. And when we use antifoulants like TBTO, that is tributyl tin oxide, tributyl tin oxide works gradually by leaking from the hull, and then it will killing the fouling organism in the surrounding area. And when TBTO and other organothin antifoulants, when they leached from the hull of the ship, and they can pollute the water present in the nearby area, and the half-life is very high. That is, in seawater, its half-life is may be greater than 6 months. So it can adversely affect the marine organism also. When we are using and also tributyl tin, using the 4-DCOI, that is 4,5-dichloro, 2 normal octyl, 2 N-octyl, 4 isothiazolene, 3 on as antifouling agents. It is found that these antifouling agents may kill only the organism that can be attached to the hull of the ship, and it cannot leach into the water present in the sea. Oh, that's why this antifoulants may directly attach to the gene of the amino acid sequence of this fouling organism and kill them. And that is according to this principle we can design a safer chemical. That's about the fourth principle of green chemistry.